Welcome at lesson number 6. We're going to speak about bulk cargo. Thanks for joining. Bulk cargo is a shipping term for items that are shipped loosely and unpackaged as opposed to being shipped in packages or in containers. We distinguish dry bulk and wet bulk. In this lesson, we're going to speak about dry bulk. Wet bulk is cargo like, for example, oil or gasoline or diesel. We do that another time. Dry bulk basically consists of small particles. Here there's a conveyor belt and they're gonna spout trim the remaining amount of tons to make the surface a bit flush. The head is movable. We call this spout trimming. And when they finish the present hold with a ullage of about half a meter, they're gonna close the hatch cover and most likely go to the next hold. So we distinguish a couple of sizes and dimensions and dead weights among the types of bulk carriers which are sailing around the world. What is important to remember, you don't need to know all these types by heart, but from the type name you can a little bit distinguish the route or the destination of a vessel. For example, Panamax or Suezmax, the ship is built to take a maximum amount of cargo through that canal. So it's a little bit seeking the limits to pass there, and the dimensions are maximized to that restrictions of the canals. If you can go through the Suez Canal or the Panama Canal, you are a Cape-size bulk carrier. You are a bit bigger. You need to have a longer sea voyage to reach your destination. What we've seen the last couple of decades that this type name is also sometimes given the name of the port where the ship is sailing to. For example, China is taking a lot of iron ore from Brazil. They go often to a port called Tubarão, and the dimensions and the dead weight of the vessels, specially built for the port of Tubarão, and they call the type name Tubarão Max. So the general arrangement of a bulk carrier, there are a couple of distinctions between ordinary multipurpose vessels and bulk carriers. First of all, usually there's no side tank, so here's the side shell directly. There's some frames over here to take the weight of this top side tanks, but there's no side tank. What is noticeable is that there are hopper tanks and a topside tank, which is basically also a hopper tank. And the hopper tank is self-trimming, and with self-trimming we mean that particles a little bit can fall down in the direction of the center line, and this little bit speeds up the discharge process. Another remarkable thing to remember is bulk carriers are type A vessels, so the freeboard rules are a little bit less stringent compared to type B vessels, and the reason is the distance between the hatch combing and the side shell. There's quite some distance to bridge over here, so the hatch combing won't receive so much water from sea or green water. So they said bulk carriers can take a bit more. Freeboard rules, load line rules are a little bit less stringent. Next sheet. Oh yeah, I forget to mention bulk carriers, if they do a ballast voyage to improve the behavior of the ship, the rolling period in particular, they can ballast the topside tanks, the high hopper tanks, and they a little bit improve the vertical center of gravity. They bring it a little bit more up, and in that way the rolling period is a little bit improved. it's a little bit longer, and that's better for the crew to sleep and to rest, and it's also better for the steel work of the ship, welding connections, etc. So something to remember, we have dynamic loads working on a ship depending on the wave crest or the wave trough. Where is buoyancy, yes or no? It depends whether if the ship is sagging or in a hogging condition. The sagging and the hogging condition especially has an impact on the shear strake and the bilge strake at the bottom. There's more tension when the ship is sagging or hogging. Please, if you don't remember shear strake or bilge strake, please have a glimpse at your ship's knowledge book. What is also important is torsion on bulk carriers, because they are so wide. The beam is big. In absolute sense, there's a lot of deflection of the hatch combing, and hatch combing deflection is a risk because it might impose that the hatch covers get a little bit lifted, and basically there is space between the hatch combing and the hatch cover. It basically means that the cargo hold is open to water, and that's quite a big risk for vessels like this. So we need to keep the torsion within limits. Distortion of the shape of the hatch combing. Is it still watertight? Yes or no? That's something to remember. And what they do, they put a lot of extra stiffenings in the hatch combing. An example of one of the stiffenings is this self-trimming combing plate. There are in all the four corners, and this minimizes the hatch combing deflection. It's a triangular plate, driehoekig in Dutch, over here. If we gonna make the ship cargo worthy and seaworthy, we need to read in the books. The Bible for bulk cargoes is the IMSBC code, the International Maritime Solid Bulk Cargo Code. Cargo's information is stated from A till Z. It's based on the proper shipping name of the good itself, on alphabet, and what is important to read is certain categories and risks. This code distinguishes between three groups. Some cargoes, they are in more than one group. Group A, cargo which can liquefy. Group B, cargo which can cause a chemical reaction. And Group C, non-class A or B cargo, but with another stringent risk. We're going to speak about some of those risks in the next sheets. Liquefaction is an important one. I'm a bit too quick. So what you see is you see water or moisture on the top surface of the cargo. I will show you the definition a little bit later on. If there's a lot of water on the top side in the cargo hold, it's very likely that the ship will lose stability. We're going to speak about that a little bit later on during this year, hopefully in the same block as this one. But what is nice to see over here, or it's not nice but important, that the deck line is already submerged, and most likely the hatch combing is more or less already touched by seawater. So it's quite likely that the ship will make water within some minutes, because maybe the hatches will be a little bit lifted, so you lose compression of the hatch rubber, and maybe the cargo hold will be submerging underneath the seawater. So what is liquefaction? Cargo gets liquid during the sea voyage due to pressure, ship's motion, and vibration when the cargo reaches the flow moisture point. What is important to remember that most likely, if this happens, the cargo is loaded earlier on and it was too wet to safely load. So the cargo is inside the hold. We're gonna unmoor and make the sea voyage. Due to the movement of the ship and pressure and rolling and pitching, etc., the water out of the cargo slowly comes up. And I will show you shortly in a movie how it really works. But in the IMSBC code, there are some rules. The moisture content, if shipped overseas, doesn't exceed the transportable moisture limit. And inside the code, they built in a certain margin. The transportable moisture limit is always less than the flow moisture point, and the law builds in a margin of 10%. And we speak about moisture content also in a way, but this is the maximum limit, TML, to where the FMP, the water comes up and the cargo liquefies. No liquid cargo to be shipped in the same hold as the bulk cargo. We need a laboratorium certificate to do an amount of tests. There's one test you can do it yourself on board of the ship, but it's not very precise, but it gives a rough indication. But samples of the cargo need to go to a laboratorium, and they take the moisture content and they're gonna see where is the flow moisture point of that batch of cargo. So they give a certificate of the cargo in that case. In this case, sorry, it's nickel ore, and they took 2 samples, and the water content as percentage of the TML, it's 84% and a bit. The built-in margin is 90%, so sorry, 10%. So in this case, we can safely ship this batch of nickel ore. So the maximum you could reach here is 90%. If we have more than 90, we are too close to the flow moisture point, so there's too much risk to ship that certain batch of cargo, nickel ore, and there will be, in that case, too much risk for liquefaction, so that the water after vibration comes up, and basically you have a lot of water able to freely move in your cargo hold, which is bad for your stability. So we do on board, besides the laboratorium test, where you can get an official certificate, we can on board do a quick test. We call it the CAN test. Please continue with the movie 2A and 2B. Thanks.